Welcome to Building Sustainability Podcast with me, your host, Jeffrey Hart, aka Jeffrey the Natural Builder. Every fortnight, join me as I talk to designers, builders, makers, dreamers and doers, exploring the wide world of sustainability in the built environment by talking to wonderful people who are doing excellent things. All right, it's episode 85 with Gervase Mangwana. This is the concluding part to our three-part series, this time focusing on air tightness. The first part, episode 83, was talking about Gervase's retrofit and a bit of his backstory. 84 is about ventilation and how deep to retrofit. It might make the most amount of sense to listen to those first, but I think you can probably plough straight into this if air tightness is the thing you want to know about. So this episode was actually, it came from a tweet I put out with my air tightness results for my tiny house. I couldn't work out if they were very good or not. I was a bit confused. Felt a bit let down by the air tightness testing outfit that I'd used. And that's what spawned this whole conversation with Gervase was actually him reassuring me that maybe I'd done a good thing, and also wanted to explain how the different readings are sort of different and how they are biased against little houses like mine. So I should warn you that this episode contains live maths. I have edited out some of the little number punching bits, but I've left some in, hopefully enough so that you can understand what is being calculated. Final reminder for the pack basket competition: if you become a Patreon supporter of this podcast in August, you go into the draw to win a lovely backpack. It's a hand-woven backpack. It was woven by me. I think they're very charming objects. Hopefully you do too. And you want to support the podcast and be in with a chance to win. This is also open to any existing Patreon supporters. If they want to increase their support, then they can be in the draw too. Okay, that's it. I've recorded all these intros at the same time and I got a dry mouth from all this talking. I'm back very briefly at the end. Enjoy Gervase. And be mindful that there might be a few little swears.
I just did, so I did a flurry of air tests for the RHI, for new build. So I didn't even realize, I don't know why I wasn't doing them much before, but the RHI ended, Renewable Heat Incentive, ended on March 31st. And so a lot of new builds were requiring an air test as part of their SAP count, which they required in order for the MCS micro generation certification scheme. For them to be able to get this heat pump. So they're all in this massive hurry. And it was really interesting because it's not sort of air tightness test work I normally do. I normally do retrofit stuff where I'm like, test before maybe, test during to see how it's going, test afterwards to get the result, or passive house new build, which is test during to find out, yes, it's absolutely brilliant. Oh, you want to make it a bit more incredibly brilliant. Let's do that. And then completion test for certification. So yeah, I don't generally do bog standard new build. So I did three. The first one was an old builder who built himself a place. He did have an MVHR. It wasn't a recognizably good unit, but he had MVHR, so he wanted to be good. So he'd done some notional work himself on air tightness. Don't know what he was doing. He wasn't using fancy tapes or anything, but he'd thought about it a bit and done some. Yeah. And he got a permeability of about 3, which is, it's okay. But I showed him all the sockets were leaking. A lot of his quite expensive doors, but not high-end doors. But he had a lot of glazing, aluminium. Quite a lot of them weren't, they were quite bad. So I showed him that. Went to another one, same day actually, another place. Architect had said to them, "You don't want an MVHR," so they didn't have one. She now thought, "I wish we'd had MVHR," but wasn't getting it. But the guy who was doing the SAP had told them, well, you don't want it to be too low, the air tightness, because otherwise you really should have a different type of ventilation. And they only had intermittent in there. So they were like, please don't make our house too airtight. That ended up being about a 3 as well. Builder there, I'm now trying to engage into retrofit work because as soon as I showed him, he was like, well, I can totally see that, but nobody told me how to make it airtight or what to make it airtight. You know, the architect just gave me some outline drawings. I've just built a building to regs. You know, but I get it. I totally get it. And I can also see how easily I could have done something about it. I can't do anything about it now. It's too late.
Yeah.
So I came away from those two like missed opportunities, really. You know, it's like these people could have made their houses way, way better with very little effort, really. You know, it wouldn't have added to the budget significantly, really. Not significantly, not compared to the £7,000 staircase that was going in when I got there. And then the final one I did was a lady who'd sort of built the house, not herself exactly, but an amazing, amazing place, like just so amazing. I can't tell you too much about it because I don't want it to be recognised. But she had insulated a lot, and she had very, very good internorm triple glazed windows. But she'd taken it over from the architect at a point where it was going to building. She wanted the control. She definitely didn't want mechanical ventilation. But she did have fans in all her bathrooms because you've got to have something. It's part F. You can't not. So she did have it. She just didn't want it. And the air tightness was 9. It was, you know, it wouldn't, the regs are changing in July and it wouldn't have met regs. So she had this amazingly insulated triple glazed house that was leaky as, you know, I've never seen a new build as bad as that.
Yeah.
You know?
Do you know what? I heard a story just yesterday. It was a hempcrete house, and there was something where it was a difficult build. I think it was in like a really tight space, and they sort of had to build it backwards. But they wanted to have these beams on show, and so they also wanted the hempcrete on show, and they did an air tightness test that came in at 30.
I don't even know how that's possible.
That's just like a windy barn, isn't it? That's. But he said that he plastered over all the hempcrete and it got it down to just below 10.
Wow. Because I've tested hempcrete, diathanite, and we tried to do a test to see if the diathanite was leaking. A retrofit in Crickowell, and we concluded that it was all right. It wasn't leaking at all. We think because we tested it before the finish had gone on.
Yeah.
But we couldn't kind of ascertain whether it was leaking in of itself. I mean, I think we got down to about 1 or below 1 anyway overall. So we decided the diathanite wasn't a problem.
Yeah, I think there's a difference between spraying hemp and placing it. I think the spray kind of basically puts a plaster down first. Yes, and that's a sealing coat. Whereas, placing it goes in a lot drier and is my very limited understanding of.
Yeah, and it's perhaps not as compact in the end, is it?
Well, it can't be too.
Or is it perhaps more? Is it prone to voids?
Potentially. Yeah,
I don't know too much about it.
I'm beyond my knowledge level.
Even 10 is it's so bad. 10 is so bad.
The example Lucy Pedler gave from Future Proof. Was it Future Proof?
Yeah.
She said that it's a hole the size of a cash machine in your house.
Well, it depends a bit on your house, but yeah.
Yeah, I think average house.
Yeah. And it's I mean, membranes and all, but I'm regularly testing passive houses now, and they're not difficult to do. They're just the guys that design them and the guys that build them just know what they're doing, and so they're designed with that in mind, and they'd be gutted to get anything over 0.2.
Right? Really?
It's it's around a sort of 0.1. They can just easily get to 0.1. 0.1, 0.15. That's I say easily. That's probably doing them disservice. But they take care over what they do.
Yes. And
they've got a system, and they designed with the air tightness layer as a major design informing driver. So, it's not. It's just intrinsic to the design.
I think that's something I realized from my build was that, it needs to be you need to be thinking about it at all points. It needs to really be like your focus, which I found particularly well. I've dropped a few balls on this build, I think, just because it's just me building it on my own. I think there's a huge here are my excuses. Just there's a lot of things to keep in your head, and sometimes air tightness wasn't the top one, which has led to it not being as tight as I wanted.
I still think you did pretty well, though. Where did you get to?
Well, here's the thing, and this is sort of part of the conversation I want to have. Permeability,
Permeability,
Permeability was 0.99.
You did that off your internal envelope?
No, that's what they sent me.
Oh, okay. Right.
Because
they did it off your internal envelope.
Yes, but I'm not sure how well. I don't know how good 0.99 is. I know certainly there
great.
Was. Is it?
Yeah.
I mean, I found loads of leaks when I was not loads, like 5 different leaking points when we were testing it, and they're all fixed up now. But yeah.
So it's now better than 0.99?
Yes. Yeah, it will be, yeah.
Yeah, I mean, so permeability versus air changes now, that's basically what we're talking about here.
Yeah.
It depends on the tester that you used. So permeability is the way that we do it in the regs in this country. Like sometimes I call them British regs, and then people tell me there aren't any British regs. So there's the English regs. There's probably the English regs. I think there's Welsh regs are different. Scottish regs are different. So let's say the English regs. But it's basically ATMA, which I'm going to be ashamed not to know the acronym of, but that's the air testing lot.
Yeah.
That's the protocol, and we do it on permeability, and that is so you're pressurizing or depressurizing, and very soon pressurizing and depressurizing, which we have to do in Passive House already, but we didn't have to do in UK regs, to a difference of 50 pascals between inside and outside. 50 pascals of pressure difference between inside and outside. That's our test point measure, unless you use the now accepted pulse testing method when it's 4 pascals between inside and outside. But for a blower door test, it's 50 pascals. And what the result gives you actually is a flow rate of air that is required to maintain that pressure difference in meters cubed per hour. And so you can then do with that what you will. And the 2 metrics that are most often used, although the Canadians do it slightly differently as well, is either you do it into the envelope of the house or you do it into the volume of the house.
Mm-hmm.
And if you do it into the volume of the house, then you've got your meters cubed going into your meters cubed per hour. So you get 1 over hours, and that's air changes per hour. So it's how many times does the volume of the house change in an hour at 50 pascals, right?
Uh-huh.
And that's what Passive House uses. And Passive House uses a strict volume, actually. So I don't know whether they gave you that or whether it was the way that it's done.
All I got was those 2 numbers, the air changes and air permeability.
Oh, right. So it depends on what sort of regime they're using. So Passive House, the UK regs just requires the permeability. That's done off a very simple internal surface area. So the area of the walls, the area of the floor, and the area of the roof. And it doesn't include things like going around chimney breasts or or even maybe bays if they're sort of beyond a certain kind of size, but not into window reveals. It's just a simple box. You get in, you can measure the house up very easily in most cases. That's for the area. And you do tend to mention the volume as well as part of the process, but it's not the measure that's required in UK regs. So in Passive House, you take the volume of the house, internal volume of the house, and then you remove from it all the walls, the floors, chimney breasts, Anything that kind of takes up space in the house. And what that does is make the volume smaller. And in making the volume smaller, it makes it harder to reach the target.
Right. Okay.
Yeah. They even actually, and I got caught out on this on my passive house training, they include a false ceiling as being the limit of the house. So the question we all got in our exam when I did it was this kind of fake false ceiling in a room, which wasn't even airtight to the rest of it. So there's like tiles on posts dropped down from the ceiling, kind of, but there was loads of space around them. And we were only supposed to include the volume below those tiles, which to me is ludicrous. And to Nick Grant was ludicrous as well. And I failed it. So I was the only professional air tester on the course. And we all failed the question, by the way. Everybody on the course failed it. So we've actually sort of, Nick Grant's got in touch with lots of people. We've written to the Passive House Institute and said, we don't agree with this methodology. And that's only one of the reasons why. And we'll get onto that in a minute. So that's the way a Passive House does it. The smallest volume, which makes it hard. Yeah. And the target is 0.6 for Passive House and 1 for NFIT. And the ACB standards use the same methodology. I think it's 1.5 for new build ACB building standard and 2 for the ACB retrofit standard.
And so 0.6 is the air changes?
That's the air changes on this passive house volume with everything removed. So it's likely the air changes per hour that you were given, unless he was using a passive house volume, which is unlikely unless he was a sort of specialist passive house, which he might have been.
He definitely wasn't.
Right. Then he's probably used a simple volume, which is all of your house. Now, I can see your house has not got many walls in it.
No.
But it's also quite small, so those walls will form a decent chunk of it. So the air changes is actually probably slightly worse than what he gave you in terms of it being a passive house measure. Yeah. So actually the permeability is the more accurate, if you like, figure. So the permeability is a function of the surface area of the house. And I just think this is a better way to measure air tightness. It's how much flow is going through per meter squared of the envelope. That is where the air is going. It's going out of the envelope.
Yeah.
On average, how much is it going out of it? Yeah. That's permeability, right? Rather than how many times is it changing. And the crucial difference between them is that permeability is irrespective of the size of the property or the shape of it to an extent. It's just a measure of how leaky is every square meter of your house.
Yeah.
Whereas air changes per hour favors large buildings massively because the air is leaking through those square meters, and the larger the building gets, let's get this the right way around, the bigger the ratio of volume to surface area gets, which is
right. Okay. Yeah.
Yeah. So my mum always says, when I say about this sort of thing, she says, we think about it in terms of heating, but it's an elephant versus a mouse.
Yeah.
So an elephant doesn't struggle to keep itself warm as much as a mouse does because its volume to surface area ratio is higher. Yeah. So effectively, by doing it by air changes, you're kind of favouring large houses just on that one factor. And the space heat demand is done by per square meter of floor area. So, to an extent, that's irrelevant. That's irrespective of size as well. So in a way, you could argue that the passive house methodology favours large buildings, which we don't really want to do.
Yeah, small buildings,
and it's
more
definitely
efficient.
Yeah, it definitely disadvantages very small houses like yours.
Right, like mine.
Incredibly challenging because your surface area to remind me what size your place is.
So it's 2.1 by 6.6.
And how high is it?
3 meters internal.
At the pitch?
At the pitch, yeah.
And what about the eaves?
Oh, it is hang on. I'm going to get the tape measure.
Live maths.
2.2.
Right, so average of that is 2.6. We're doing live maths here. 2.6.
Live measuring as well.
Live measuring and live maths.
That's
right.
going to translate well to podcast audio.
Yeah, brilliant. So your volume is 51.5 meters cubed.
It is slightly confusing because I've got a change in roof pitch halfway through my house.
Let's say it's 50.
We'll keep it simple.
Yeah. We're also going to have to do something a little bit funky with the roof, but I'm going to have to do this quite quickly. Obviously, you can edit this out, can't you?
Yeah.
Due to the reveal at the end. So you've got a surface area of 74 square meters, and your volume is 51 square meters. So your surface area is significantly larger than your volume.
I see. I get. It's all become clear now. Yes.
Yep.
Yeah.
74 divided by 51 is 1.45. So yeah, your surface area to volume ratio is 1.45. Many houses are roughly parity.
Right.
You know, a lot of them, most of them are much bigger than yours, but I regularly do this stuff. So I get both measurements. In the simple case anyway, to get in the passive house volume for a minute. So most houses are kind of more than 200 cubes big and like up to sort of 400. And unless they're very weird shape, the surface area and the volume are roughly the same. I think I'm right in saying that a 6 meter cube box has exactly the same, because it's got 6 sides.
Yeah.
I think I'm right in saying that it's 6 times 6 times 6, it's 216. So that would be the volume of it. And then you've got 6 by 6 squares. So that is also 6 by 6 times 6. So a 6 meter cube box has got exactly the same volume as it has surface area.
Right.
Now that's a very uniform shape. So
yes.
that's
Real
a bit
life.
of a factor.
Yeah.
That's a bit of a factor. But a 10 square meter, so like 10 times 10, that's going to be just ridiculously huge, isn't it? No, I've been in houses that are 1,000 cubic meters, right? So a box that's 10 by 10 by 10 has got 10 times 10. It's got 6 of those. So it's got 600 square meters of wall and 1,000 cubes.
Okay, yeah.
So
it's gone the other direction there.
It's gone the other direction.
Yeah.
So its surface area to volume ratio is 0.6. Yeah.
Yeah.
So when you're doing the permeability of that house, you're dividing the flow rate by 600. And when you're doing the air changes, you're dividing by 1,000. So the air change rate is much better.
Yeah.
Yeah. So what was the air changes for your place?
1.87.
That suggests to me that he might have taken something out, because we've just worked out the ratio at 1.45, and those two, that should be the ratio of between your two values. If you've got 0.99 for your permeability, your simple sort of UK regs air changes should be 1.45.
Oh, I see. Yeah, of course.
But because it's worse than that, that suggests that the volume was even smaller still. So he may actually have taken out, I don't know, he may have taken out the thing. Without seeing the numbers, it's a bit hard to say.
Yeah, and, is that the sort of thing that I could get from them? Because I was expecting a full report. No.
You would have got one from me.
Yeah.
Let me tell you.
Well, do you know what? This is the thing I wanted to talk about, because my previous air tightness experience is in your house, done by you. Yeah. And that's sort of what I thought I was going to get.
Right.
What I actually got, and no discredit to the guy, he said it was the best result he'd ever seen for a start. And he wasn't really that interested in properly sealing up the building, like the vents. Yeah, his thing was going and testing like bulk homes where they just wanted to. He wasn't
interested in sealing the vents, though.
Not particularly. Not to a standard where it wasn't a bit leaky.
Right. Oh, okay. Yeah. No, that would be fairly standard. Yeah. I mean, and that's because in a bog standard large or much larger than your home, a bit leaky air vent's not really going to make much difference.
Right.
You know,
It's quite a big factor in mine.
Yeah, exactly. Yeah. So yeah, no, you want to see them. No, I mean, you'll have seen the door as well. It's not the best seal, is it?
No.
So I kind of get this. I know when so the godfather of air testing, low energy air testing in this country is Paul Jennings, and he does Mike Whitfield's houses, and they've got a system where there's a smaller fan, and Mike will make up a ply panel that fits that fan, and he'll put it into a window.
Right.
Somehow they fit it into a window opening somehow.
Yeah.
And so that can be just properly sealed. Whereas the blower door thing itself is inherently quite leaky. And my understanding of this, all this kit was designed in Canada and America some time ago. It hasn't been changed. There's only two brands. There's only two blower door systems in the world, and they're both, one of them's Canadian, one of them's American. And my understanding is that they accepted the fact that the door fan was a bit leaky in itself around the edges because doors were. So it was like, well, this is kind of like the door that's there. So, but things have changed since then. So, last one I did, they always have a bit of, my builders have a bit of a mutter about, what about the door? So last time we taped the door frame into the door as well.
Right. Okay.
And tried to get rid of as much of that as possible.
Yeah.
So, yeah, you should get a report from them.
Okay.
Like, he'll have used a piece of software that spits out a report. You should get, should at least get the flow rate.
Yeah.
And if you've got the flow rate, then you can do your own calcs.
And that's I think what I want to do. There is a whole load of other things. Like, we deliberately didn't seal up the stove because I wanted to know what actually is. My interest was not about passing a test; it was about making the building as best as it could be. So I wanted it to be a real life test.
Doors are closed on the stove, though, obviously.
Yes, stove is sort of closed down. It's just maybe I've approached this in the wrong way.
No, you haven't. It's like, so there's two methods of testing: method A and method B. Method B is the one that we use for regs because it's testing the actual fabric. Mm-hmm. And that means sealing up all intentional penetrations.
Okay.
Which would include your stove and your fans and any trickle vents.
Yeah, don't have trickle vents.
No, you wouldn't. But, in a normal house, conventional house. Thanks for that word. I'm going to use that a lot. Yeah. And method A is the kind of as found situation, which is really useful. Definitely, because that's how the house is performing. So you've definitely done a bit of a hybrid because your fans are there as well. So you've sealed your fans up, but you've not sealed your stove up. And what the modelling software does is it knows, it works out how much the ventilation is doing, and so that's a ventilation loss. It's separate, and then it makes assumptions about what a stove is doing, how leaky it is. In the case of SAP, it also air bricks and any other flues and whatever, and some stuff about kind of how high the building is, so that whether it's making a stack in and of itself, that kind of stuff, and how exposed it is, how many sides are sheltered, that kind of thing. All that kind of goes into an overall infiltration and ventilation losses. It all gets fudged together into a big loss. Or a small loss if you've done your work right. So I don't think you've done it wrong. From my point of view, a stove is leaky. I'm just interested in how well you've done the air tightness in your.
Well, me too. Yeah, I suppose. Yeah, that's probably.
And now you don't know.
Now I don't know.
No. It's pretty hard to seal stoves.
Is it?
Well,
it's a direct air. As you'd expect. It's all grommeted in and out.
Oh, well, in that case, I wouldn't worry about it.
Oh, really?
It should be fine. Yeah. Well, it's presumably should be pretty well sealed to the room then.
Well, yeah. I would have thought so. I'm not. It's sort of a bit out of my knowledge.
yeah. See, if I'd been there, we would have been finding out.
I know. I should have got to do my.
Well, yeah, I'm not sure if I could have come down to it. I do have a kind of, lovely as it would have been to come to X. Well, I don't know. I'll bear it in mind if I'm ever down that way, because when I've got the fan on board, it's fun to do more. Yeah, but that's what you do really. It's totally justified not sealing the fan then, because it's supposed to be in on of itself airtight.
Yeah.
So no, you've done the right thing there. Absolutely, you've done a method B test. You've closed open fans. Yeah.
Okay.
And you'd assume that it's not too bad. It's meant to be sealed to the room, isn't it? So
yeah. I definitely didn't know whether I should be happy, sad, or what with my results. I had in my head air changes of 0.6 is like the gold standard, so on one hand I was pretty miffed to be fairly far from that, but also now understanding that that's maybe not the most applicable or fairest way to test my house.
Fair. That is absolutely right. It's just not fair. Like you're like the 0.6 target, which is pretty arbitrary anyway. Let's face it, is very hard to achieve in a very small home. It's much harder to do it than in a normal sized home. So that 0.6 was chosen not with 50 cubes of air in mind, not in the slightest. It was in with places at least 4, 5, 6 times bigger than that in mind. So I think to achieve an air permeability of 0.99, let's call that 1. No, we can call it 0.99. Let's call it 0.99. It'll make you feel better.
Sub 1.
Sub 1, yeah. Well, and this is the thing, is like you identified significant leaks.
Yeah.
And you've sealed them.
Mm-hmm.
Yeah. So, you're definitely sub 1 on the permeability, aren't you? And like I say, for normal buildings, there's a kind of parity. Yeah. So you can kind of think of it, if it was a normal building, you'd be about the same for air changes an hour. The only reason it's not is because you're in a very small building.
Yeah.
So yours is a kind of classic example of where, you're at an extreme in terms of the form. And I had this conversation with somebody about Sylvan's trailer. You're kind of up against it with the heat loss as well, and yet the heat loss itself is actually very small because it's very small. So you don't need to kind of get too worked up about it. And actually, how are you going to heat it if it's you're going to find a heater that's small enough to? I mean, you must have a very small wood burning stove, don't you?
I have small wood burning. It's 4 kilowatt, which is, I've just run it for a very short amount of time.
Right.
And it's very easy to go too hot.
I'm sure.
Yeah. And then it's kind of like the canal boats, and I'm suddenly opening all the windows.
Yeah. It's log, is it, presumably?
Yes. Yeah.
It's not modulatable. That's the problem, isn't it? Really, you just get what you get.
Yes.
Yeah. And you've got almost no thermal mass, so.
Basically, well, yeah. I went for wood fiber insulation because I wanted a bit of thermal mass.
Yeah.
Yeah, and then I've got cork on the walls, which has a little bit of mass. It's not.
Yeah.
It's not anywhere near like like your house or
what
I'm used to. It's like slapping in a big earth floor. There's none of that.
No.
I was considering doing a little kind of brick or cob surround on my stove just to be a bit of a heat store. Yeah,
that'd be a nice idea, wouldn't it? Yeah. I mean, some of them come with, don't they? There are some. So where did you get your direct air? Who's your direct air stove?
That is a Saltfire.
Saltfire.
Yeah, it's the Saltfire Scout.
Scout, okay.
And it's the reason that one is because it's only 100 mil to combustibles on the back. So it's got a real sort of designed for very small spaces.
Okay, right. With burny stuff nearby.
Yeah, exactly.
Right.
A big
Cool.
a little timber box that you want
Right.
a stove
Yeah. Tinder box. Yeah.
Yes. Well, yeah, you could call it that.
Yeah. So I think, we've covered permeability versus air changes, which is like, it's a really important message to get across, I think, especially for people who are interested in tiny homes, is, permeability is a much better measure of air tightness. It's a much more useful one, less depressing.
And what are the limits for permeability in terms of sort of building regs? And
I've just written a piece for the ACB about this. So the way that the regs work with most of the metrics for energy is that they've got a backstop, which is you shouldn't go worse than this.
Mm-hmm.
And then the way I understand it is like there's a notional house. So there's a notional house which says, okay, let's work this, which you can sort of think of as best practice, I suppose. But the whole thing kind of gets thrown into a full calc and ends up with, at the moment, what is an emissions target. So, you can kind of win over there and lose over there. So the backstop for air tightness is at the moment is 10,
right,
which is awful.
Yeah.
Like, I mean, I've been doing social housing stuff in Northampton. Houses were built in 1922 and are not that well maintained. They are solid brick, but they've still got some suspended timber floor as well in them. And some of them were like 4 or 5. So 100-year-old houses that aren't in great nick are like twice as good.
Designed for air tightness.
Weren't designed for air tightness at all. No. Are twice as good as the backstop for the UK regs. They have increased that. Oh, sorry, they've decreased it. I've made it better as of July to 8, which I think is wholly unambitious.
Is that a deliberate pun? Wholly.
Yes, I suppose it is. Yeah, thanks. Yeah,
very good.
Yeah. It was completely unintentional. Thanks for spotting it. Oh my goodness, I'm gutted now that I didn't spot that in the piece I wrote. Yeah, but I understand the sort of the notional value is 5, and I've always heard that. So I don't think that's changed. I think 5 is kind of considered best practice. And again, I just think it's awful because I think it's really unambitious. And I did a little exercise. Because I can use the SAP tool that we have, and because the UK regs is done off SAP, I sort of said, what is if you kind of use the notional house, which has a set of U values as well. So if you plug in sort of some notional, I can't remember what I did, but some notional house size with a notional amount of windows, a certain amount of glazing, some of it south facing or whatever. Basically, I had a house that had one window on each side that was quite big, so they kind of got the shading and the solar gains and stuff in it as well. Stuck a couple of people in it, made the air tightness 8, made the air tightness 5, put in some Part F ventilation, regulation ventilation in it, and the biggest loss, if you have the air tightness at 5, the biggest loss overall, not the walls, not the windows, not the floors, not the thing, it's the air tightness. And if you put the ventilation and the air tightness together, I think it accounted for nearly 40% or 50% of the overall losses. So, it's sort of kind of we're like deliberately building buildings with this target that is, and like I said, I went to 2 places where they really didn't know what they were doing, hadn't really had much of a go at it, and they got to 3. So why aren't we aiming higher than that? Especially when people can do it, design it, and do it at 0.2 without really, it doesn't cost a fortune. So to me, 5 is ridiculous. I mean, 8's really ridiculous. Sorry, 8 is completely ridiculous. 5, still pretty ridiculous. Yeah.
Am I right in thinking if you just sealed up the building to sort of 0.2 without addressing any sort of insulation or anything like that, like what the improvement in performance would be quite a big jump?
If you got it to 0.2, yeah. I mean, especially if you could manage to get MVHR in as well.
Yeah.
Which is sort of unlikely. I mean, this sort of speaks. Yeah, you'd have a big. I wish I had some numbers to hand.
Sorry, I've just kind of surprised you with that.
No, with a factual question. Yeah, and I should really. It does vary from house to house, but typically it's sort of probably in the 10 to 20. The air tightness is 10 to 20% of the losses, the heat loss. Probably. It does depend very much on the house type. And then if you take it down to 0.2, that's pretty much eliminated. It's gone, effectively. The reality is you can't do that. Well, I mean, you wouldn't do that. So one of the exercises we've been looking at is getting down to 2, which is 10 times worse than 0.2.
Yeah.
But, 4 times better than 8 and 2.5 times better than 5. Yeah. And it's the retrofit. I'm talking retrofit here. This is the retrofit, ACB retrofit standard. So it was like, we were looking at a cavity wall place. So if the cavity wall's been filled, it's got loft insulation, you get the air tightness down to 2, but you don't do the walls and you put some ventilation in, does it make sense to have a heat pump on it? That was basically the kind of question that was coming up. And it does make sense to do that. But what we found in doing the social housing schemes I've been involved in is, because I've just been really involved in the air tightness testing in one particular scheme, and where they have been doing the walls and they have been doing the windows and they've been doing some stuff in the lofts, but they're not doing the floors, is actually they're going to find it really hard to make much improvement at all to the air tightness because you can't get people out. So they're still living in these houses in their...
Oh, get them out as in to do the work.
Yeah. So doing significant air tightness work really does... You need to kind of get into the nitty gritty. You can do some draft proofing work, but you've kind of got to do quite a lot of work to get down to 2, even to get down to 0.2. You have to... If you're starting from scratch or you've gone back to the skin, like I did here. So this place I got to 0.3. I retrofit. I got to 0.3, which is, it's amazing. It's absolutely amazing. But, it was thought about and, designed in, and it was completely stripped out. It was totally and utterly gutted. It was it was a carcass for a long time. And at that point, it's, there are some challenges still, but you can see what they are. So you can deal with them. If you can't see what they are, you're always kind of chasing shadows. And like the big ones in houses are between the floors. So you've got joists going into pockets in walls. Usually those walls haven't got any kind of plaster on them between the floors. And if it's into a cavity, you don't know where's it coming from. What
do you do in those scenarios?
Well, you have to have the floors. You have to cut out a bit of the floor and get something down between. That's the only way. Because you could argue let's seal the floor above and seal the floor below, but you're still then letting wind pass backwards and forwards across the house. You're kind of having a cool floor in the middle of your house. It's probably still a bit better, but it is a bit better, but it's still not. It's still not. And the air tightness result would actually look better, but you'd still have a cold slab of floor potentially in a windy day in an exposed site on a cold day between.
It's kind of just like having an uninsulated wall, isn't it? Just in.
Yeah. It's the thermal bypass straight through the middle of your house. Yeah. And the same with suspended timber floors. It's very hard to deal with them. Although at least then you can try and deal with the top deck. So if you don't want to have exposed floorboards, you can go to town on that and go to town on the edges. But you can't really do that without all the stuff coming out. And in social housing, there's not really a stomach for getting tenants to do that, or taking people out of their community for significant periods of time, or rehousing them, which is on the stock owner, on the housing associations to deal with. So we're starting to accept that 5 might be the most realistic target for that, and then you start to realise that actually you are going to have to do some more to the fabric in order to get them down. And social housing is the area where we feel probably we should be making the biggest attempt to reduce demand, because those are the people who are least able to pay for the bills. Whereas all the able to pay market, that you can kind of accept that they should get on a heat pump because they probably use more energy anyway, because they probably heat a bit longer, apart from the very conscientious ones. and they can probably afford the bills more. So, let's get them on a heat pump for the least possible, but let's do a bit more to the social housing.
I'm not sure if this is Scotland, but my understanding was that if you get beyond 3, permeability of 3, then that's the point you have to have mechanical ventilation. Is that?
I should know this, shouldn't I?
If you want to look it up.
I think it's not that. I think it's that beyond 3, you have to have continuous.
That sounds like it, yeah. Because I remember before in my days of thinking that natural ventilation was an acceptable.
I remember those days myself.
Yeah. I was like aiming for just more than 3, because
right.
I was in that camp of thinking, whole house ventilation was in some way bad.
Well, in some ways it is bad.
Do you want to expand on that?
Well, it depends on the technology. Yeah, so you're reliant on something that can go wrong, and there's a capital expenditure for it, and it uses energy. So, in comparison to doing nothing at all and opening some windows when you feel like it, there are some significant disadvantages. I get it. It's and if you're the kind of person, as most people are, who aren't not very tech savvy. I mean, the intermittent extract strategy probably accounts for 95% of the ventilation in the country. Maybe a bit, well, in theory it does anyway. But in reality, when I go to people's houses, most of their bathroom fans either don't work or they're not used.
Yeah, it's so thick in like fur and gunk.
Yeah. Interestingly, the social housing ones, they've got a lot of them. Because they've all been through a scheme, which the Housing Association got money for. So a lot of them have got continuous extract, single point continuous extract, and they are in a bit of a state, a lot of them, but a lot of them were well used. And a really interesting thing, so in those houses which were tight, and they were like 4, like I said, those people had their trickle vents open and their fans working. They inherently knew that their house was not drafty and that they needed to appropriately ventilate it. They didn't know it. They were like, in one case, they were the kind of people who you just wouldn't think that they would get that kind of stuff. Yeah. You meet a very interesting range of people in social housing work. I mean, in some cases, like tragically so, really tragically so. But they just had a feel for their house that it wasn't that it needed the ventilation. So they did it and they ventilated appropriately. Those places which were inherently leaky, they hated it because they knew it was drafty. They were cold because it was drafty. They were closing up all the ventilation, and they had mold problems as a result because they didn't, the poor stuff was not where they really wanted it to be. The holes were not given the ventilation in that room, so they were closing it all down because it's drafts. And then the backs of their cupboards were were moldy and whatever.
Yeah.
So, that's, like I say, it's a kind of inconvenient truth. Yeah. You need, if you're going to ventilate, if you're going to build tight, you need to ventilate right. But that does mean that we depend on the technology and that there's an energy cost. But it also means that you have to pay for decent ventilation as well. And that's it's something that people's just not on their radar. People get that they have to pay for a heating system. They don't get they have to pay for a ventilation system. And so they balk at the kind of costs of decent ventilation. But then when they pay for indecent ventilation, they turn them off because they're too noisy, or they break and they don't replace them. And then they complain because they've got mold or they don't know that they're like sleeping in very high CO2.
Why is it that you test at 50 pascals? What is that?
I don't know.
What is that creating? Is it because I had an inkling that it might be that's the pressure that like a big storm could create.
It's a very small pressure difference.
Right.
It's tiny.
Pressure is a Pascal. Who knows what a Pascal is in terms of...
Yeah, Pascal is... so I think we measure atmospheric pressure in hectopascals. I do anyway. Okay. And which is hundreds. And I hope I've got this right. I think it's 1,000. So it's around... Pressure is around 990, between 990 and 1,010. I very rarely see it outside of that that range. And and I'm pretty sure that's heptopascals, not kilo hepto. I don't know why that is. I think that might be because it's similar to another one of them. There's a lot of metrics for pressure. You've got millimeters of mercury, which is, kind of old school. And then you've got bar, and then you've got PSI, pounds per square inch.
Yeah.
So I think heptopascals is the same as one of those, and I forget which one it is. But yeah, so atmospheric pressure is then 100,000 pascals.
Right. So 50 is really
50 pascals is a tiny pressure difference.
Yeah.
So it's just a pressure difference that you're getting.
And it's a set in stone,
Well, it is for blower door testing, and I think probably the reason for it is although it's a tiny difference, so we're required not to go above. I should know all this stuff really well. I think it's 80. Well, no, we get a bit of a red flag on software. It's 80. I think really don't want to go over 100 because you can start blowing things.
Like
you start breaking
the tape.
Well, more like things in houses that you don't want to break. Like I'm trying to think of an example. Can't think of an example. The sort of stuff that's meant to stay tight doesn't stay tight anymore.
Yeah.
At that kind of level. And then if you get really low, atmospheric conditions start to play a much bigger part. So when you do a test, and your guy will have done this probably, hopefully, a proper regs test, you actually don't do it just at 50. You do it at a range. You start at kind of 75, and then you work down through a whole load of them. A minimum of
he
8.
was adjusting a little.
Yeah. So you do a minimum of 8, and they've got to have a certain spacing, and it has to go through 50, and then that gives you a graph, and the graph is sort of normalized, and so the point where that crosses 50, that is the at 50 choice. Yeah. Whereas quite a lot of the time when I'm not doing a certified test, I use a cruise method where my fan can kind of maintain 50, and so it fluctuates and tries to constantly to maintain it, and then I run it for like 10 or 15 minutes, and it averages it all out, and so I get an answer that's close, and it's a lot easier to do, and it means you can run around finding where all the mistakes are and do that. So I suspect that the reason is that it's nicely in the middle of the range between not being too badly affected by atmospheric conditions and not causing a problem.
Got you. Because I did after I'd fixed some of the leaks, I put both of my fans on my MVHRs onto extract. And I was thinking, am I going to break things by doing this? I imagine the pressure that they could create isn't going to be big enough. But I could still feel a little gap that I then closed up.
Right.
Quite useful for.
So you put them onto boost.
Yes, exactly.
Yeah. So I mean, I can tell you what. So your permeability was 1, and
0.99 actually. Sub 1.
Yeah, your point was sub 1. So and your internal surface area is 74.
Yeah.
So the flow rate was just over 74 meters cubed an hour.
Okay.
The flow rate divided by the surface area is the permeability.
Yeah.
Yeah. So, my MVHR does 167. Much bigger place, obviously. That's at whatever it is, 30%. That's not its boost rate. So yeah, there's a good chance that I don't know without knowing the units. But that's 74 cubes an hour is a bit of a trickle to a decent ventilation system.
Yeah, great. Yeah, I was concerned about it going too far. I didn't want to start breaking things.
It wouldn't have broken anything, but you could, if you got a smoke pen.
I got some smoke matches, which I found were over the top.
Okay, too much smoke.
Yes, too much smoke.
Yeah, so they do one that's more like, it looks like a pen, and it's got a wick in it, and you can kind of click a bit out, and you set fire to it, and then blow it out, and it kind of glows and gives you a bit of a few pounds. So you probably got enough flow on your extract that you could test your stove.
Ah, yes.
It's better doing it the other. Oh, you can't boost the supply, can you?
Yes. Yeah, I can set my units to when they go on boost, they can either go extract or supply.
Right. So you want to pressurize it because you'll see the smoke. It's a bit easier to see the smoke disappearing into the crack than it is.
Yeah.
I mean, you can still sort of see it getting blown by the air coming into the room.
Yeah.
But yeah, it's sort of nicer to see that there's the smoke. Oh, it's going.
Yes.
So it's going through the crack.
Yeah.
So, get yourself a little smoke pen, put your fans on supply boost, their max, and then have a go around, see if you can find it anywhere that's leaking.
Great. So I was surprised that the Veluxes, my single Velux, there was a leak coming from the actual window itself. And I was pretty miffed at that. I thought...
I would be too.
And is that like...
Are they made by Velux?
Yeah.
Yeah. It's Facro, isn't it? Facro.
What does that mean?
Sorry.
I don't know what that means.
Facro's they're the kind of go-to manufacturer.
Oh, as in like the ones I should have got.
Sorry. Basically, yeah.
Okay, fair enough. That's lessons learnt.
Yeah. It's probably not a major deal.
Yeah, I've only done a winter so far, and I'm very.
We'll be back after a quick break.
Hey there, I'm Mick from the Mick and Pat Show.
That's right, and I'm Pat.
Looking for a podcast that's like catching up with old friends? Well, you're in luck.
We're here to bring you weekly doses of lifestyle commentary, discuss culture and politics, and top it off with the occasional beer and film reviews.
But it's not just about us. We're a community. Our listeners are our kin, and we let you all have a say in what we discuss.
So saddle up and join the conversation at the Mick and Pat Show. You can check out our website or find us wherever you get your podcasts.
I'm sure it's a small place, it's a small place. And, I can only reiterate, better than one. And, given that you found 5 findable leaks, you're definitely better than one. And, it'd be lovely to know how much better than one you are, but
yeah,
we'll have to wait and see if that transpires. And by the way, it's very hard to test that low.
What do you mean? Why is it?
Well, because you've got to get a fan that's only delivering less than 74 meters cubed an hour.
Right.
And you saw the size of the fan that guy was using, right?
Yeah.
So, yeah, it gets the slower the fan's going, the slower the fan's going, again, the more susceptible it is to kind of atmospheric changes.
Right.
They kind of get more challenging. So, yeah, I'm going to get myself a smaller fan. And he'd have been putting rings. Did he have a yellow and a red one, or did he have a black and black?
He had 2 different rings. He tried different ones. Yeah. I mean, that was my first question, because I'd seen, I think Nick Grant mentioned somewhere on Twitter, like, people laughed at me for having my small fan.
Yeah.
And so that was my first question to my air tester was, this is a very small house.
Are you going to be able to do it?
Can you do it? And he was like, yeah, no problem.
Let me get my manual out. So I've got a
look at that.
It's like
it's a hand.
So it for testing you use the software and all this stuff, but it has actually got a thing that it shows you it actually doesn't do it on flow rate. It's not measuring a flow rate.
Uh-huh.
It's measuring the pressure in the fan.
That's why they're poking that little thing outside.
That's the reference. So it's reference because it's a pressure difference. So the 50 inside and outside. So you've got one pressure inside, and so it's actually you're doing 2 pressure differentials. Yeah. It's a manometer, it measures pressure difference. So it's 2 channels. So one is measuring the difference between inside and outside, and it's trying to get that to 50 or whatever it is you're trying to get it to. And the other one is the difference between the fan and outside. And the fan and inside if you're depressurizing, the fan and outside. But anyway, it's the fan against the reference. And then the fan is calibrated against that pressure. So it's been to a lab and they know how much air it's delivering at that pressure with that given ring. So mine's got a whole bunch of rings. I've got 5 rings on mine, and I have mine calibrated for the 2 extra very, very tiny rings. It's just like I've got a little hole in the middle of it where you have to do something a bit funky and extra. And then in here, it's got in my manual, it's got a thing that shows me what air it's delivering for that pressure. Unfortunately, in cubic feet a minute because it's American, so you have to kind of convert, which is slightly annoying. But I would have been able to do it. Yeah, you would be able to do it on D or E, but would you be able to do it on the? Most people don't calibrate those rings because they never ever get in a situation where they'd ever need them. Ring C, yeah, nowhere near. Yeah, so there's absolutely no way you'd get anywhere near it. 89 is the lowest. 89 times 1.7. One of those useless numbers I know. Well, it's useless to most people, but converting from cubic feet a minute to meters cubed an hour is 1.7. So yeah, on a sort of normal rig, the lowest flow I could get to would be 151 cubes an hour, and so that would have been, there's no way I'd have been
double what.
Yeah, at 50, and I'd have had to have got below 50 anyway to be able to do a sort of proper test. So I like I said, I'd be using the extra rings. I expect that's what he was using, but there's a good chance that his machine isn't calibrated for that, because I very much doubt he's ever had those rings calibrated with his fan, because I mean, not that that's likely to make a huge difference, but it might make some difference. Of course, it might make some difference in either direction, but it is a struggle for doing small buildings and very, very tight buildings. So I'm going to get another fan that they do what they call a duct blaster. So it's for doing ducting systems. And they do some extra rings for that as well, because it actually kind of delivers the same air as this one, because it's for very big ventilation systems, but they actually do some more restrictive rings for it. So you can get it down a bit lower for doing like these stupidly tight buildings. I've got a workshop that's 30 square meters, and I actually haven't retested it, but I tested it before I'd taped the floor, I think. And I think I had my son, who was 6 at the time, did some of the taping. I got him into taping, and he helped me do the air test. So we're going to retest it now that it's finished. And I struggled a bit with that, and I think I got it to about a similar. I figured if I could get it to 1, I'd be happy. So I think you should be really happy with 1. I think you should be really
good.
Yeah.
Sub 1.
Yeah. Sub 1. Yeah.
Why do you pressurize and depressurize? You mentioned earlier that.
Yeah. So some holes, some leaks have different characteristics, and the most classic example I can give you is a loft hatch. So if you pressurize, depending on the way the loft hatch closes actually, but most conventional loft hatches, they sit down they use gravity basically, don't they? And they're not clamped. So if you pressurize, there's a chance that it slightly lifts that up, so it'll be worse. Whereas you depressurize, you're sucking it closed, and it's actually artificially better than it would be in ambient conditions. So that's why it's required to do it both ways. And it's interesting, like quite a few of the passive houses I've done recently, there's been a noticeable difference between them. And so you average them. And in both cases that I can think of, it was a bit hard to work out why.
Right. You couldn't find
couldn't find the offending thing. No. But we're talking about tiny margins. That's the problem. It's, when we're down at those kind of.
When I was wandering around trying to find my little leaks, the breeze is very, very minimal. Like when you're down at the sort of point.
Well, the breeze is still the same. The breeze is still the same. Yeah. It's just less of it, less of them. Yeah. I mean, and the breezes get smaller the bigger the holes get.
Yes. Yeah, that makes sense.
Yeah. So, yeah. So the worst holes the biggest holes are actually quite hard to find.
Yeah. Oh, well, that makes me feel better.
Yeah. But it also probably means if they were, if it was small holes that it was like coming through, it's probably not going to make a huge difference to your result.
Right. Got you.
Yeah.
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 Yeah. This is there's a lot more.
But don't worry about it. Sit back and relax and enjoy your abnormally airtight home.
Thank you. I mean, the guy when he tested it was like, "Whoa, I've never seen anything this good." And he was like, I should pack up and go home. I was like, no, we're going to find all those little leaks.
And that's the thing, they're not interested in it. And I get, I've got a slightly snooty. There was a couple of jobs. There was a job I really wanted to do in Manchester actually because it's people that I knew, but there was a QS involved, and I was outpriced, and then they were really unhappy with the job. The QS wasn't; he didn't care. But the people that I was, the architects that I was doing it for were like, we didn't really get what we wanted out of the process.
Yeah.
We got a number and we're not even that confident about that.
That's exactly how I feel.
So I do sort of stress to people now, and I had it, and again, I had somebody who'd been priced, somebody who was local. Quite a lot of times I'm going quite fast, so the travel is the thing that makes a difference. But I can't do volume. I can do it a lot quick doing those social housing. I can get in and out damn quick now, but I can't really do it without having an interest in what's going on.
Yes.
It's difficult for me to turn that function off in my brain. It's just all part of it. And that's why the guy that you did, he'll have just done completion tests.
Yes,
I
think so. Yeah.
So it's too late to do anything about it. I don't get it as a principle. It doesn't make any sense at all.
Yeah.
Let's find out how bad it is after we can do anything about it.
Yeah. He said his normal time is 20 minutes just to do the test.
God, it takes me that long to set up. Yeah, and they're so cheap. How much did you pay?
250.
Bloody hell. Yeah, that's cheap. That's a lot cheaper than me.
Is it?
Yeah, it is. Yeah,
I'd probably have preferred to spend more and got like a Gervase level.
Yeah, I think I sort of do it a bit on complexity. The travel would have cost you more, but I sort of local tests around. Yeah, no, and I tend to do them in packages as well. Mm-hmm. So I'll do them as I'll do your 2 tests, and then I only have to measure it out once, that kind of thing. And also I'm familiar with the building or whatever, or just a bit of kind of bog off.
Yeah.
Not bog off, but bog cheaper.
A catchy phrase.
It's not going to catch on, is it? But £100 more than that, plus the travel.
Yeah.
So if I was nearby, it would have cost you. It probably wouldn't actually. It probably would have cost you not much more than that. I think. Yeah, if you're not putting the effort in to find stuff, and also you get a written report as well as your software report from me as well. You get a kind of a bit of analysis on it. And you get your volumes and your flow rates and your kind of all that stuff in it, and you get the written out where the leaks are and
all of this stuff which I just assumed would be standard. So it was a good learning opportunity for me. That I suppose. It's assuming. So often you don't know to ask the questions. No,
you don't find out what the questions are until afterwards.
Yes,
so.
Exactly.
Yeah.
But now we can pass all that knowledge on to the listeners.
Yeah, absolutely.
Yeah.
The
other thing that I found quite alarming was that there was a couple of places that I could have chosen that offered a no pass, no fee guarantee on their air tightness testing, which just seemed like you're setting up to like fudge the test. Yeah, and it's that sort of different mentality. You and I want to make the best buildings possible, and other people want to do the least amount to get through the regular.
Yeah, it's just a tick. It's a tick to say it's I could talk about this stuff endlessly. Up until the regs change coming about now, it wasn't required to test every building. It's going to be required now to test every new build. And bizarrely extension. I don't know how the hell they're proposing that's going to work, but extensions are supposed to be air tested too.
Right. What would you seal off the rest of the building?
Yeah, so like loads of extensions don't have a seal off, do they?
No.
They're kind of open plan. Let's have an open plan extension to our kitchen. I don't know what else is going to work. But so on developments, there was this kind of equation, like every type there had to be 2 or half, which was ever the least, something like that, done. So every end terrace that was the same, you had to have 2 of them done, every terrace. And every one of the rest of those that wasn't tested got their SAP calc got put in for 2 points worse. So, if the house was, the one they tested was 3, then all the others are going at 5.
Okay.
Yeah. And the idea was that the testers were supposed to choose the house at random. But in reality, my understanding is, and I've never operated in this world, but my understanding was that what happened quite a lot of the time was they'd turn up and the developer would say, well, that's the one that's ready.
Yeah.
So,
they were led to choose
reality,
the one building that they could.
Yeah, which they'd gone, which they could have gone to town on. So in reality, you really don't know what the others were like. They could be literally anything, probably not 30, but because I think you'd have to work really hard to get a normal house to an air tightness of 30. I think the worst I've seen is a flat that was 22.
Wow.
Yeah, that was social housing as well. Yeah, and I think it was because the suspended timber floor, so it was a mid-floor flat, and the suspended timber floor, I think they must have had some problems, but I went outside and there was it was on a little outrigger, so it was a tiny little thing, and all the way around the interfloor void, there was just like tens of air bricks around the outside. Right. So there was just, it was basically just a massive hole into the floor space, and it was very small. So yeah. Yeah, that does sound a bit alarming. No pass, no fee. But I think that sort of stuff's going to change.
So is it changing July?
Yeah, and pulse testing is coming in now. So that's a totally different way of doing it. It's a kind of ultrasonic, I think.
Okay.
And it's done at is it pulse? I don't know. I don't know enough about it, actually. But there's two things that I don't like about it. One is that there's three things. The first one is it's not what I do. So, yeah. And the other two are what I gather is it's a bit difficult to compare. Mm-hmm. So that instead of being 50 pascals, it's 4 pascals. It's a bit, apparently there's algorithms that have been developed so that you can kind of say, okay, what would it be at 50 then? But that's still a work in progress, as I understand. And they're kind of changing those algorithms as we speak. Still, they're going to go through it as a learning, even though it's been accepted as it can be a regs test now. But the other one is that you can't use it as a diagnostic.
Right. Yeah.
It doesn't give you that at all. So in order to do your diagnostic, you don't need a result for your diagnostics. And that's why Nick made his fan the way he did it. Mm-hmm. And I think Mike Whitfield's got a fan, and I know a couple of other people are getting a fan just to depressurize the house, and go around and sort of find stuff,
Yeah.
It's nice to have the number, because otherwise you don't really know what you found and what you've made it better to. So yeah, to me, every house should be tested not once but twice, because by the time it comes to a completion test, it's too late to do anything about it. Mm-hmm. And I wish I'd said that in that piece now. The problem is that's expensive.
The testing twice.
Yeah, it's already expensive testing every single building once. Testing twice adds more costs. Developers are always like, we're just talking about the scale stuff here. It doesn't matter for one-off buildings. But for scale builders, they're like, what more? And it's difficult to sequence it as well, because you've got to have the air in order to test it. What you're testing is the air tightness layer. We've seen on this social housing stuff, I've gone up to do 4 or 5, and they're supposed to have got X, Y, and Z done. The windows are supposed to be in, whatever, it's supposed to be done, and you've got to get 5 of them done so that you can do them all at once. Otherwise you're backwards and forwards, and but because you want to be able to do something about it, you can't have done the next stuff that covers it up. So it is difficult, but if we want good performing houses, we haven't even touched on how the problem of, it's not just about the energy loss. Air leaks into buildings lets moist air into insulated. You've got condensation risk, structural, especially in timber frame, so it's not just about energy.
Brilliant. Thank you, Gervase. That is 3 monster episodes. So much information. So pleased that we could get you on and chat through this stuff. And personally, this certainly this last episode, it felt like a little bit of a free consultation session for me. So thank you very much for that. One of the perks of being a podcast host, I guess. A reminder that I am taking a little break from the podcast, from just life in general. I'm going to go on a big bike ride. And yes, so there'll be a little delay before the next episode. Reminder again that there's the pack basket competition. Get yourself into the draw for one of those if you become a Patreon supporter in August of 2022. And if you have a chance, share this episode, share the podcast, say nice things, and let's see if we can get more people learning how to build sustainably. That is it. Be happy. I'll be back soon. Cheers, everyone.